Good afternoon, everyone. Meteorologist Steve Caparata here in the WAFB First Alert Storm Center. Happy Friday. Hope everybody watching today is healthy and doing okay as we continue through these crazy times. So for our kids watching today, I'm going to walk you through a couple of little, not experiments, but ways you can make your own weather instruments at home. We're going to walk through a little make your own thermometer. We're going to walk you through how to make your own barometer. So for the kids that were with me for my very first weather lesson, that was sort of the intro to weather, we talked a little bit about air pressure and how air has weight. Well, a barometer is the instrument we use to measure the weight of the air and how the air pressure is changing through time. So that's one of the instruments I'll be showing you how you can make a little simple version at home today. Now, having said that, I'm working in kind of a cramped space here, so we're going to make this work as best as we can. I'm going to cut back and forth some between the graphics and the camera so I can kind of show you what's going on and how to do this. Now, hopefully you have a lot of this stuff at home already. If you want to build along with me today, I've got a couple of examples already built, but I'm going to try to walk you through it too just to show you what can be done as we look at building a thermometer and a barometer today. All right, so let's start with taking a look at how you can make a thermometer at home. So here is the simple list of things that you would need to gather if you want to play along and do this with me right now. Just get a bottle. Now I'm going to show you here in a second. That could be a water bottle. It could be as big as a 2-liter. It could be a smaller glass bottle, as long as mom and dad say that's okay, but something like that. If you've got modeling clay, that works really well. If not modeling clay, Play-Doh will probably do the trick. Food coloring helps, but it's not necessary. We're just going to drop a couple of drops in the water. That helps us see things, but you don't need that to do that today. Be honest with you, the thing I've had the toughest time coming up with is a clear straw. I found a bunch of straws. I had a little trouble finding a clear straw. I got one. I'm going to show you a couple examples of the end product that don't have a clear straw here in a second, just because I only could find one. Even ran in a store this morning just to see if I could find some more, but I could not. So let me bring this back on camera real quick. So for the thermometer, I'm going to show you a couple examples here, and they're pretty rough examples, but it's going to show you just kind of how simple it is what we're doing today. So here's one I built. This was a 20-ounce water bottle. Looks pretty basic, doesn't it? Now, it's not quite finished, as you'll see here in a moment, but I just wanted to show you. If you've got a water bottle at home, this will do the trick. Now, let me bring this in closer if you can make it out. You can see a little line on the straw. I think this one probably came from McDonald's, so not a clear straw, but you can still kind of see the water move up and down in the straw. So that's one that I made this morning. I also found laying around a little Gatorade bottle. If you got one of those little Gatorade bottles at home or something similar. Again, little plastic bottle. Here's the modeling clay at the top. Again, this is a white straw, not a clear one, so that's not perfect, but I am going to show you. We're going to build one here with a clear straw in a moment. But this is basically what the end product's going to look like. So you say, how am I going to measure the temperature with that? Well, that's what we're going to show you today. All right, so let's get back to it now. So if you've got those things together, here's what you would do. First off, what we're going to do is take our bottle. So I've got another bottle now. I've got stuff scattered all around, so bear with me as I do this. So I've got this glass bottle because I figured it'll show things a little clearer. So again, kids, make sure if you got glass, you're working with mom and dad, or you have the okay from them to work with the glass, but this is one I've got this morning to work with. So let me go back to the scene, and I'm going to move my camera here while I'm doing this. I'm going to show you how we start setting this up and how we start making our thermometer. All right, let's take a look at how our camera looks. So again, I'm having to wing it here a little bit, guys, with this one web camera that I have to move around. So here's our bottle, though. So the next thing I'm going to do that you don't have to do, almost dropped it, don't be like me, kids. So this is covering up the label. So that's a little red food coloring. Mom and dad, again, kids, make sure mom and dad give you the okay to use this. Unfortunately, the one I bought does not have a little dropper on top that makes it easier just to get a drop or two out. So you don't need a lot of this. So what I've done is just stick an extra straw in here, and I'm just going to try to squeeze out a drop or two of this because we don't need much. Let me grab a little more, and Mr. Steve's already making a little bit of a mess here, but we dropped a little bit of water in there. Here's the other important thing to have on hand, a little napkin, kids, so in case you do spill a little bit like I did, you can wipe it up pretty quick. Alright, so now that we've got our food dye in our water bottle, that's going to help us kind of see. And what I'm going to do here, let me grab the top for this that I have laying around somewhere, but we're going to mix this up. Well, I don't know where the top is, but we'll shake it up. We're going to mix this up. And then the next thing we're going to do is we're going to take the clear straw. So I found a good clear straw for parents maybe looking. This was one that goes in one of those like bigger plastic cups that we happen to have laying around the house at home. So maybe something you want to use. So here's the straw I'm going to use. The next thing I'm going to do, I picked up some modeling clay. So these little sticks of modeling clay like this. Again, if you don't have something like this, you can use Play-Doh. We're going to kind of shape it. You can start to make it into a circle if you want. So we're going to start shaping that a little bit. We want to leave a bit of a hole in it for the straw to go through. We're going to take our straw, put it through our modeling clay into the top of the bottle. And then as we push the straw down, let me lift this up. You don't want the straw to touch all the way at the bottom. You want to leave a little space, okay? Otherwise, the water that's inside is not going to be able to move up and down. But once we've got our straw kind of in there, we're going to take our modeling clay and try to lock that straw into place, kind of mold it around the straw. Now, depending on the straw you're using, this one I have is kind of a thicker straw. It's pretty strong, so it doesn't pinch easily. But moms and dads, if you're doing this, you want to make sure you don't pinch the straw. We want the fluid to be able to move up and down in it freely, so if you pinch the straw, that may cut it off. But at the same time, while we don't want to pinch the straw, we do want to try and make a seal up here at the top as best as we can to get this working as well as we can. Alright, so now I've got my straw in there. Now, there's a couple ways we could go about this. Let me go back to our graphic here. So we could put a little card up at the top of the straw that we could use as a guide for what the temperature is. What you're seeing here is fill the bottle with water about halfway to 3/4 full. Again, we're leaving a little space at the bottom. But instead of full with the index card, which you can put that up at the top here if you want, but that gets a little trickier to work with. So what we're going to do instead is we're going to warm up the water and then let it cool off, and we can actually kind of mark the line. So let me come back. We're going to bring this back full screen. So the idea with this thermometer, guys, is as we warm this up and as we cool it, as we warm it up, we should start to see the red liquid, the red water, rising up in the straw. And then once it cools, it starts dropping down. Now, if you're at home and you have like a thermometer that can go in water, or maybe a candy thermometer, I had one of those home I forgot to bring, you can measure the temperature of your water. Once you measure the temperature of your water, then you can just take a Sharpie like this, mark a line, and write that number. And from then on out, you'll know when the water's sitting at that line. So let's say, in fact, here, I'm using kind of a high-tech tool today to figure it out. So this is what we call an infrared thermometer. It'll measure the temperature without actually contacting the water, because I don't have one to stick down in there today. So I'm going to point it at it, and then I'm going to get a reading. So it's saying that it's 77 degrees inside that bottle right now. So I would draw a line right here, mark 77. Now, if I've done this right, watch what's going to happen. So here's the next thing I'm going to bring in. Borrowed this from our dressing room. So a pink hair dryer. Doesn't have to be pink, obviously, but I found a hair dryer. So we're going to heat up this water a little bit. And if you can hear me over this, so you see the water rising up. Let me get that red streak out of view. But did you see how the water is now risen up in the straw as I heated it up? Why is that? Well, as we heat up air, it becomes less dense. That means it kind of spreads out. It takes up more room. That starts pushing up from the bottom of the straw, and so that's telling us that it's getting warmer. So what you can do, I don't have time to step through different temperature levels today, and you guys would probably get bored with me, but if mom and dad will help you, you can warm it up and then measure a different temperature and mark some different lines, and you set different marks on the bottle, and then from then on out, as the water moves up and down, you'll know what those different temperatures are. Another way you can accomplish that, mom and dad, is if you took maybe a bowl of water, and you got one bowl and you heated it up some. Again, keep the kids at a safe distance, but heat up the water, set our bottle inside of the hotter water. That'll do the heating for you. Or you can get a bowl of some ice water and put it in there and watch how the temperature reacts and the water drops inside of the straw. And then, in my case, again, I've got the infrared thermometer, but if you had like a candy thermometer or something else, you can measure the water on the inside and get an idea of how warm or how cold it is. You make some different marks on the bottle, and then ultimately you've got a completed thermometer. All right, and that's what my graphic is showing you here. I took the card off that they suggested, so again, I think it's just easier. You just draw some lines on the outside of the bottle. But if you're paying attention, do you notice how the liquid is dropping down inside of the straw again as the air cools? So when air warms up, guys, let me see if we can point this up a little bit. So when air warms up, it takes up more space. It spreads out. Why does that happen? Well, the molecules that make up the air, they start moving more. They start bumping around, and the air spreads out. When air cools off, the molecules on the inside start slowing down, and they clump closer together. They get closer together, and the air becomes more dense. It contracts, and that allows our water on the inside of the straw to sink on back down. So we can see how things move up and down as we track it. So does that make sense, guys? Take a peek over here. All right, so that was a real basic explanation how you do this. Now, I will, hopefully later today, just been real busy, hopefully later today I'll post a step-by-step guide on how you can do this and maybe finish it off a little better with those lines. I'll actually tell you what the temperature is, but those are the basics. It's pretty simple. You take a bottle, some water, a straw, and then some modeling clay or Play-Doh, something like that, and you've got a thermometer at home that you can use to kind of track how the temperature is changing. All right, so we did the thermometer. Let's go on to a barometer. So to make our barometer today, here's a look at what you would need if you want to do this at home along with me. We need a glass jar of some kind, a pencil, another straw. This time around, the good news is the straw does not have to be a clear one, so that's a little bit of good news there. A spool. Let me show you. Well, we'll show you that in a second. So like a spool of thread. If you don't have a spool of thread, I'll tell you. In fact, let me grab. Bear with me as I reach down into my bag. Something else that worked for this. For moms and dads that, like me, that might have a lot of these at home. Here's a little tiny tub of Play-Doh. I'll show you in a moment how if you don't have a spool, this will do the same trick. So if you want to grab one of those, if you don't have a spool laying around, that will also work. We need a balloon. You want to have a balloon on hand. And then this time we do, if you can, you want to have an index card or a piece of paper and just something, a pencil, a pen, a marker to write on that piece of paper. And so I'm going to step you through. Well, first, let me get my finished product and we'll give you a look at that. So bear with me a second again while I get my finished product over here on my desk, and I'm going to let you guys take a look at it. I got to move my webcam around. And I want you to see what this looks like. Hang on one second. Alright, so let's see how my webcam's looking. We've got to re-aim that a little bit. And I know this isn't the best shot, but here it is. So, we've got a glass jar. On top, I've stretched a balloon over the top. One thing I didn't mention, if you've got a rubber band, that'll help hold the balloon on top once you put it on. Here's our straw. Now, on the end of the straw, come around this way, I've taped on a toothpick. Now, here's our spool. We're taking the spool of thread, we put a pencil down in the hole in top of the spool, and then we tape this little paper on that'll measure high pressure and low pressure, how it's trending. Alright, so there's a finished product that I made, and now we'll step you through how you can do this yourself at home. Alright, so let's get back to the graphics. Let me adjust my camera once more. Get me moving the camera around a lot, so just bear with me as I do that, as I move things back around. Alright, let me move my finished product out of the way. So you see the items that you need to do this along with me at home. Here's how you basically do it. So at that point, you know what, let me just come back on camera, full screen. So I'm going to back up. So here's another jar I have, another glass jar. So again, kids, be careful if you're losing glass. Moms and dads, if you have a plastic container, that would probably work just as well. Now, one key, moms and dads, as you'll find out in a second, since we're going to cut a balloon and stretch the balloon over the top of this jar, you don't want it to be too big. You're not going to have enough balloon if you have something where the opening gets too big. So you're gonna find out live on air if we can even live here, at least on the web, if I can even execute this one, because this is probably the trickiest part. So once we have our jar, we then, I'm looking around at all my supplies, we get a balloon. I forgot my scissors. Let me grab my scissors. And so I'm back. So we take our balloon, and what you're going to do, and you might have to experiment with this a little bit, moms and dads, but you're just going to cut some of that part off, some of the neck of the balloon, if you will. Alright, so here's how I've kind of cut it off. The neck, the part you blow into, you can toss that aside. And then you start experimenting. You're going to stretch this thing out. And let me see if I can point it down. And then the trick is to try and get this over the jar. Alright, so we got it on, but that's not how we want it to be finished. So if you got a big air bubble like this, we're just going to try to pull on the sides and stretch it out some more until you can kind of flatten it, get it as flat as you possibly can. Alright, and this is where, you see, this is where I had two sets of hands with this part when I did my own, when I did the one I showed you, so it doesn't hurt. But there we go, that's better. So you stretch that over the top. You see that now? Alright, in fact, let me do. So you see I've got it pretty flat on top. Once we've done that, you don't have to do this part, but it helps. I've got a rubber band. We can put that around right at the top, and that'll help keep our balloon in place, hopefully. Just trying to straighten that out a little bit. Alright, so now I've got a rubber band kind of wrapped around the top. Not perfect, but good enough for now. So the next step in the process, I'm trying to see if we can get out of the glare here a little bit. Alright, so the next step is to get another straw. Got a straw. And I tested this out. You can use something like a glue stick, okay? So this is kind of a less messy solution. So we're just gonna dropped it. But we're just gonna put a little bit of this glue stick on one side of the straw. And then next, you want to try and attach that to the top. Put a little pressure and see if that holds. Okay, looks like it's sticking, so that's good progress so far. So the next step in the process is going to be getting, well, I thought I had it stuck. So we'll put a little more glue on the balloon here and see if we can get it to stick. This straw is probably a little bit heavier than the one I used earlier. But the next step, if you're doing this along with me, and if you had better luck getting yours to stick than I did the first time, the next step we're going to do is grab a toothpick. You can use a sewing needle too. I like a toothpick better. Obviously with kids, the less sharp the better, even though a toothpick is kind of sharp too. Grab a piece of tape. We'll put a piece of tape on that toothpick, and then we're just going to stick it right here on the end of our straw. And I still don't have this stuck well enough on the balloon. But you can trust me because you saw I have a finished product, right? So this one live is going a little slower. But there you go. That's the hardest part of it, especially getting that top on the balloon. Let's see if we can get a better view of this. So, jar, balloon stretched over the top, rubber band around the neck of the jar, straw that's kind of glued on top of the balloon, and then we've got a toothpick that's taped on to the end of that straw. So next, I'm going to take part that I've already built. So we mentioned a spool of thread. Alright, so here's a spool of thread that my wife had at the house. And you see how it's got a hole right in the center. Well, as it turned out, you might play around a little bit, maybe with some different spools, depending on what you have in the house. But this pencil right here fit perfectly. So what the spool does, it's really all it is, it's serving as the stand. So this is where I said the alternative, if you don't have a spool, a lot of you with kids, well, that's not the one. Let me get the right one. Here, if you don't have a spool of thread, if you have a little thing of Play-Doh, this is the other way I did it last night, and you can see the hole still in there. But we got a container full of Play-Doh. You could literally just stick the pencil down in there too. The bottom line, like I said, this is just a stand to hold the pencil and to hold our scale. So once we've got all that, you want to line up and keep in mind, as we draw these lines, they're not representing specific values. What we want to see is the trend. So you're kind of lining up the toothpick with that center line as best as you can. Let me pull my spool, had it lined up a bit better on my other jar. There goes my straw again. But I promise you, if you glue this right, it works. You can see my original one still holding together. And in fact, let me bring my camera down and give you a little better view of this. Alright, let's see how that looks. So there's a little better view. Let's see if it can come around. Alright, so now we've got basically our barometer right here. This is what's going to tell us how the pressure is going higher or lower. And here's our scale for measuring it. Now, how does that work? Well, I'm going to show you an example. So what we expect to see, now we've got this balloon on top, when the air pressure gets higher, the balloon should sink into the jar a little bit, and that's going to make our toothpick go, wait, I said that backwards, I'm sorry. When the air pressure gets higher, the balloon's going to bubble up a little bit, and you're going to see this toothpick go up. And then when the air pressure gets lower, you're going to see the balloon bubble down, and you will see it drop down. So watch what happens again. Got the hair dryer. We're going to heat up the jar. Alright, so you see how we heated up the jar, and now our pressure gauge, if you will, our barometer, it is dropped. That's because generally speaking, if you heat things up like that, we're going to get, in a small scale, we're going to get lower pressure. That's going to give us lighter air. So, can you make it out? Our balloon has bubbled up a little bit because the pressure is lower. Now, if the pressure gets higher, that balloon is actually, sorry, I'm running out of cord here. That balloon is going to sink down into the jar, and then the needle will go the other way. So, let's come back on camera here. So the kids that were with me from our first weather lesson might remember we talked about air pressure, and I said high pressure gives us happy weather, and low pressure gives us lousy weather. So with our little barometer here, what we want to track is the trend. If we see it trending towards high pressure, towards the H, then we know there's probably better weather on the way. If we watch it, and remember, this is going to happen slowly over time. It's better to watch this from, say, look at it at pick noon one day, and then look at it noon the next day, and see what the trend is. Has it moved up or down? If it's moved up towards the H, towards high pressure, we might have some nicer weather on the way. If it's moved towards the L, towards low pressure, then that might mean we have some rain or some lousy weather on the way in. High pressure, the air is heavier, and that's why we get that reaction of the balloon. If the pressure is high, it's going to push down on that balloon, and the air is heavier, it's going to push down on that balloon, and we're going to tilt up towards the H on our scale here. If pressure is low, that allows the balloon to actually cave in a bit, and it's going to tilt down towards the L, towards our low pressure. Alright? So hopefully you're keeping up with that. I know this is a little complicated. Wish I had a better setup to show you. But the bottom line is, pretty cool way to kind of track, an easy way to kind of track what's going on with our pressure and our big weather systems. Alright, so this is what the graphic's going to show you. Here's our finished product. If the air's pressure is lower, then the balloon sinks in. Our needle tilts down towards the L, telling us that we're getting lower pressure, lousy weather. If the air pressure is higher, then the balloon's gonna, I keep saying this backwards, but the balloon's gonna, let me back up here, guys. I'm sorry, I keep saying this backwards in my head. So, we'll get back. If the air pressure gets lower, the balloon's going to bulge up, and you're going to see the needle tilt down towards low pressure. If the pressure gets higher, the balloon's going to cave in toward the jar. That's going to tilt our needle up towards high pressure, and we know nicer weather is on the way. So that's how you make a barometer at home if you want to give it a try with some things laying around the house. Now, there's one last thing I wanted to show you guys before we wrap it up. this is how you kind of, the next thing I'm going to show you is how you can experiment with static electricity and get a look at how lightning works. And this one's actually pretty simple. So we talked a little bit about this in my first lesson, Intro to Weather, on how lightning forms. Here's a little better look at it though, a little better graphic I've got for you now. So when we've got a thunderstorm, lightning's all about opposing charges. You get negative charges, negative electrons, that's for the older kids, but you get a negative charge at the bottom of the storm, at the bottom of the cloud, and then down on the ground we get positive charges gathering on things like trees and things like that. We get this stepped leader that starts, let me get my pointer to show you what I'm talking about. We get this stepped leader that starts coming down as all these negative charges start to collect. It continues to build down towards the ground, that stepped leader. That starts to draw these positive charges up. We like to say opposites attract. So the negative is trying to meet up with the positive. Well, eventually, we start to get those two connecting, and then eventually, as they connect, we get this return stroke. That's the lightning flash that we see as those negative and positive charges connect. Lightning is all about opposing electrical charges, negative and positive charges coming together and forming an electrical current. So here's a way you can kind of see how that works real easy. Let me bring you back on camera. All right. If you have a balloon, if you brought a balloon today for a barometer, if you have any more laying around, got one here that I've inflated. I did this with my kids last night. I think they got a good kick out of it. Real simple way of doing things, so of seeing how this works, guys. So take the balloon and just rub it on your hair real fast. Rub, 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 rub. And then we lift up, and can you make out my hair's not real long, but my hair starts to stand up? If you got longer hair, or mom or dad's got longer hair, and you try it on them or try it on somebody with longer hair, you will see their hair really sticking up after you do this. So what's happening? Why does that happen? Well, when we rub, we're really creating those opposite electrical charges. We're getting a bunch of negative charges in our hair, a bunch of positive charges on the balloon, and then the two want to connect, and that's what makes your hair stand on end. So try that out at home, and that's a much smaller example of how electrical charges connect, how lightning eventually works. Now, that's not going to hurt you. It's a very tiny current that happens when we do that, not enough to hurt us. Lightning obviously is very dangerous, so we want to stay away from that, but there's no danger. You can get the same effect by if you're wearing, if you take your shoes off and you rub your feet on a carpet real fast and a lot, and then touch something or touch someone else, you might get a little shock. That's the same thing happening. You're separating electrical charges and then making them come together. All right, guys, that was all I had to show you on these couple of weather experiments I put together today. So hopefully, I know it's a little rough bouncing back and forth on this webcam trying to watch, but ultimately, I think you saw this works if you do it right. So here was our thermometer. I'll show you one more time. We're going to tilt it down towards our thermometer. In fact, let me just bring the camera down. Alright, so I'm going to take my hair dryer one more time, heat it up, do you see the liquid coming up through the straw? That's our thermometer in action, telling us that the air is getting warmer inside of the bottle. Okay? And then we showed you the same thing. You can kind of experiment with the hair dryer and your barometer, and that's kind of fun once you make your barometer. Kind of neat to see how it reacts up and down as you heat and cool things. Alright, hopefully you learned a thing or two today. Let me move my stuff out of the way and take a peek, see if you guys have any questions for me. How do you put the thermometer in the water with the straw in the bottle? So, the important points to remember here, well, there's a couple of you play around with it and you'll figure it out, but what you can do, and let me get another piece here. So I had my sticks of modeling clay. Some of you just might have some Play-Doh, but a good way to start is if you got the modeling clay or if you got the Play-Doh, make a circle first like that. And then you can put your straw in the middle, then put it down into the bottle. And from there, we're going to start molding our clay or our Play-Doh to fit the lip of the bottle and the straw to A, hold the straw in place, and to B, we kind of want to seal off. We don't want air going in and out of the bottle. Okay, so you want to try as best as you can to make a seal around this part. All right, Zane says thank you. You're welcome, Zane. Appreciate you tuning in. Looks like not too many questions here. All right, just taking a peek over. Looks like Regina watching with her 8-year-old. Thank you, Jean or Jean, 9-year-old watching. Tiffany says she had fun making the thermometer. Good, good. Glad you guys did. Thank you from Ava and Owen. Thank you guys for watching. Appreciate it. How many different types of thermometers are there? That's a good question from Noah, age 9. So Noah, chances are your mom and your dad grew up. Maybe they did. Somebody my age for sure did. Depending on how old your mom and dad is. But a lot of us moms and dads grew up with what was called a Mercury thermometer. The concept was the same as what we did here in our bottle. It was much smaller. It was a little glass tube that you put in your mouth, and it had liquid mercury. The mercury would react to changes in temperature. On the outside that little glass thermometer, there would be lines showing you 97, 98, 99, 100 degrees, and the mercury would move up and down as it got warmer and cooler. Mercury thermometers don't get used much anymore. Why is that? Well, number one, mercury is pretty dangerous. So when those glass thermometers, sometimes they would break, because guess what? Kids break things sometimes, right? You don't want to be handling that liquid mercury. That's kind of dangerous. So that was problem number one. And number two, mercury overall, that liquid mercury was kind of bad for the environment. So they stopped making them. So then we've got this kind that I showed you. This is called an infrared thermometer. So if you were with me, whether I think we might have hit on this in both of my intro to weather lesson and our hurricane lesson. We talked about infrared satellites and how they sense temperature. Well, this one has a laser beam, and it is able to detect the temperature by just, can you see the beam hitting the bottle? And then it'll give me a temperature. I know that's a little blurry, but that's an infrared. So it doesn't actually have to touch the object to actually measure the temperature. I had one of those at home. I forgot to bring it, but I borrowed this one from our engineers. And then I know with my kids, we have a thermometer that you run across the forehead, a temporal thermometer. There's a bunch of them. When you go to the doctor, what they do a lot of times, probably stick it in your ear. Sometimes you have the ones that go under your tongue, but most of them work under the same kind of idea, okay? But there's a lot of different types. All right, let's see if there's any. Can this work outside? Yes, but with the thermometer, one thing to keep in mind, if you leave it outside over a course of days, some of this liquid will start to evaporate through time. So your scale is going to get less and less accurate if you leave it out there for a long time. The seal, if you make a good seal, that should help limit some of the evaporation. And that's kind of the point. But it's not going to be perfect. But it can at least give you an idea to watch how the temperature goes up and down. But it will. But like I said, the other way to do it is just get a bowl. Put some hot water in there with mom and dad helping. Put some hot water in there. Then take your thermometer, set it down in the bowl. Watch how it reacts. And then put some ice water in that bowl. Put your thermometer down the bowl and watch how it reacts. Why does the water go up when you blow dry it? So when we warm up air, the molecules, these are tiny little things that make up the air around us, they start moving faster and faster. They start bouncing into each other, and that makes the air expand. So as the air starts to expand or take up more space inside of our bottle, that starts pushing up from the bottom of the straw. That creates some pressure that starts pushing up, and that pushes the liquid up through the straw. So we know when it gets warmer in here, the air that's inside is going to expand, and that's going to start pushing the liquid up. So that's why that happens. Let's see if there's anybody else. Yeah, somebody else asking about will the thermometer work outside? Carter, yeah, we just answered that. It'll work. Just keep in mind that the liquid, some of that liquid on the inside of it could evaporate eventually with time. It's another topic we talked about in my weather lessons, evaporation. So evaporation is when water changes from a liquid to a gas, right guys? That happens when you warm it up. So if we warm up the water, the liquid in our thermometer, eventually over time, and it's very warm outside today and again tomorrow, that will cause some evaporation. So that means if you set your scale right now, you draw a line here and we say, okay, this is where the water is when it's 75 degrees. Another couple of days where you drew that line for 75 might not be so accurate anymore because some of the water will have evaporated. Even if you may not even be able to see the difference, but you'll start to lose some accuracy with time. All right, I think we got most of the questions. I'm just checking. So as I get ready to wrap up here, again, hopefully y'all learned a thing or two today. Let me tell you about what's ahead next week. Some of the younger kids will like this, but also I'm doing this, readjust the camera, doing this for some of the older kids. So next Wednesday at 1 o'clock, Eric Blake, he's a forecaster at the National Hurricane Center in Miami. He's going to come on live with me. Not live, and he won't be here in the studio, but we'll get him via Skype or something like that. We're going to talk to Eric about his job at the National Hurricane Center. He's worked down there. I lose track of time. He's probably been there 10 years or more. Probably even longer than that now that I think about it. But Eric's originally from the North Shore. I think maybe Madisonville. So he's a Louisiana native. But he also has an interesting background from college. He went to Colorado State, where he studied with one of the tropical meteorology, the tropical weather legends, a guy by the name of Dr. Bill Gray, who passed away, I lose track, probably 5 or 6 years ago, something like that. But he was a real pioneer in tropical weather, Dr. Bill Gray, and that's one of the people Eric did a lot of his studying underneath. So should be real interesting to hear from him both on that perspective and what he does at the National Hurricane Center. And hopefully the kids, you can ask him about his job, but maybe just some questions about how hurricanes work, since we did a lesson on that, but you can ask him too. And then next Friday, April 3rd at 1 o'clock, Danielle Manning, she's a forecaster at our local National Weather Service office in Slidell. She'll join us. She's been there for a number of years too. I don't know how many. She's been there a good long while though. And she can tell us about her background. coming up through college, what her path was like, and what her job is like at the National Weather Service. Because even though we all work in weather, I work in weather, Eric Blake works in weather at the National Hurricane Center, Danielle Manning works at weather at the National Weather Service, all of our jobs are a bit different. So I wanted to give the kids out there an idea of some of the different paths you can take in meteorology and weather and what's involved, some of the ups and downs maybe. I'll tell you right now, no matter the path, if you're going to get into meteorology or weather, one of the key things to keep in mind is that weather happens all day and all night, right? Weather doesn't sleep. So that means when we have bad weather at night, or if we have bad weather on a holiday, somebody's got to be working. So that is one of the things you have to consider. Working our job is we sometimes work kind of crazy hours. We definitely work holidays. Somebody's always here. We do newscasts 365 days a year. So somebody's always working. Christmas Day, Thanksgiving, you name it. And it's the same at the National Weather Service, so they can tell you about that. But they work kind of different shifts than we do. So I think you'll be able to ask them a lot of questions. So that's what we've got lined up for next week. And then from next week, from there, we'll see what happens into the following week. See if we can maybe line up some more stuff. One last point. A couple of you have asked me about getting these on YouTube, especially teachers. I'll see if I can get that done. I know some of you wanted to send out the link so maybe the kids could watch some of these lessons and learn a little bit. So if I'm able to get that done, I'll let you know. All right, we'll go ahead and wrap it up for now. But guys, I appreciate each and every one of you for joining me. Kids, hope you learned a little bit today about making a thermometer for measuring temperature and a barometer for measuring air pressure. And we even took a little look at lightning and static electricity with the balloons. So that's all I've got for now. Again, thanks for joining me, and I'll see you on TV, and then we'll see you back here next Wednesday at 1 o'clock.